Okay, we're back. This is chapter 2, part 2. We're going to carry on with the storage measurement. Now, to understand storage measurement, we have to understand that at that very basic level within inside of the hardware, that computers really only save or store either an on or an off in that binary number system. They refer to that as a bit. Now, of course, humans can't interpret that. We have to type in characters, and those characters then have to be translated into bits. So what they've done is they've grouped 8 bits together, and by organizing 8 of them together, they can have a unique pattern that associates with a unique number that they can associate with a unique character. So at its most basic storage capacity, they're called a byte. So 1 byte equals 8 bits, which is also equal to 1 character. So every time you type a character, that's 1 storage location. That's how you can think of it. It's quite straightforward. Now, when we talk about storage in any kind of storage capacity, whether it's a USB drive, it's a hard drive, it's an SSD drive, it's a cloud storage, whatever type of storage you're talking about, we're measuring it in bytes. That's the number of keystrokes to store that particular file or information. So they break it down usually in groups of thousands or increments. So when you get a 1 kilobyte, that's 1,000. A megabyte, of course, is a million. A giga is a billion. 1 terabyte is a trillion, and so on. Then there's petabytes and exabytes. So as we've increased our storage capacities in cloud storage and with SSD drives and so on, the number of capacity to store data has continuously increased. So they're going to ask you questions like, what is a trillion bytes referred to as? And you would say, well, that's a terabyte. Or what is 1 million bytes? That's a megabyte, and so on. Now, you probably know that because you probably have USB drives, and it's probably a 16 gig. And 16 gig is 16 billion bytes. But if you break that down, you have to multiply that actually by 8, which gives you actually the true number of on-off zeros and ones of binary bits that particular storage capacity stores. All right, let's have a look at the computer operations. So a computer, hence the name computer, what does it do? Its primary function, the computer physical hardware, is to calculate or to perform some sort of computations, to compute computer functions. And there's basically 3 different tasks that a computer does. It does that arithmetic operations, logic operations, and it stores and retrieves operations on how to store and retrieve those operations. So when you get the question about what is the main functions of a computer, there are 3 basic types that you need to remember. A computer, what does it do? It does very well. It adds, subtracts, multiplies, divides, raises to the power of. It does all these sort of mathematical calculations. It performs comparison operations by comparing 2 numbers. So for example, if you were to take 2 is greater than 1, that would equate not to a numeric value, but to a Boolean expression, which would be either true or false. So it would say, is 2 greater than 1? And that would be true because 2 is greater than 1, for example. So that's one of the computer functions that it does is it does comparison analysis to come up with either a true or false, sort of like a 0 or 1 type of thing. Another component is it stores massive amounts of data in a single space and located in a particular, so you can search it up and gain access to that information quickly. And those are the main functions that a computer does. Now, again, back to the same thing, and this is really coming from the textbook and the slides, and it's kind of getting a bit redundant, I think, here, but to use a computer and process data, 3 major components are needed. Of course, we need input. What does a computer do? It outputs, and it also has memory. So again, input, process, output, but they're adding this other one here called memory, because without memory, a computer can't really hold the information to properly process it, to be able to output it. Input devices are devices that send information to the computer, and the most common input device that we use tends to be the keyboard, but there are lots of other types of input devices. We've got a mouse, we've got the touch screen, we've got light pans, trackballs, all sorts of ways of collecting data and be able to input that data into a computer system. So here's some acronyms: optical character reader. This is where you can use a light type of pen to scan text, and it takes that, optically recognizes it, converts it into a character, and then it accepts that individual character into the computer. Magnetic ink character recognition. This is where you've got on a piece of paper, like a little strip. It's kind of an older technology. Magnetic ink character recognition. You might think of this on the back of your credit card. On the back of your credit card, you got that little magnetic strip. It's encoded with a bunch of characters on it. And optical mark recognition. This would be another type of system for inputting data. Now, outputting data, we've got some of the main output devices that we use would be, of course, the monitor would be one of them. Can you think of a couple here before I give it away? Speakers would be another one. So anyway, we can output information to the user. So we can do that in the way of printers, listening, visual, are all different ways that we can accept information from the computer. All right, you can display outputs in the form of what they refer to as a soft copy, which would be on the monitor, and a hard copy, which would be in the form of a printed copy, so you can physically take it away. Although it seems like more and more the trend is going towards soft copy outputs compared to hard copy, because we're just not really using much paper, especially now that most stuff is online. Although there still is a need for paper, but we're drastically reducing the amount of paper that we're printing. All right, so there's other types of output devices. You'll see this if you take an example of one of these new devices like the Alexis or the Google Assist or these other devices, or Siri. They have this voice synthesizing to be able to output. I mean, what type of output does one of those devices have? All it has is the voice. It talks to us, and it's in a very human way. Now, another main component of computers is the memory. So what they call the main memory, which can be called the RAM, the random access memory. And this is a temporary storage, a volatile storage. This is our working memory. This means when you guys are typing data, you're using your keyboard to input the data into your computer. What's happening is that information is being entered into the computer. It flows through the bus. It gets entered into the computer, it gets saved into the RAM, and then gets sent off to the CPU, or the CPU then can direct it to the RAM. And it's volatile, meaning that it only works as long as there's power. So if you're typing something out and your computer goes off and you haven't saved it, it's gone. That's why they call it volatile. So RAM is very fast, it's relatively inexpensive, but it's volatile. That's why we need a secondary memory system to be able to store the data, the output. So the data can be stored and the outputs can be stored, and we do that in the secondary output. So something like an SSD drive, not an SDD drive, an SSD drive. So that's the solid, should be say a solid state drive. And this is a non-volatile data. These are a little more expensive. This is like RAM that almost has like a power supply to it. It's not really a power supply, but when you flick on those little binary switches inside that SSD drive, it maintains its location until there's a circuit to switch it back. So it's non-volatile. It holds all the information. Now, how long does it hold it? I don't know. Could be years. I'm not sure of the thresholds of how long data is actually stored on that. I know with CD-ROMs, back in the old days, the CDs used to be able to save these for years, but they do degrade over time because the plastics in them actually start to break down, and over time, I'm not sure if the life is like 50 years or what it is for those. You use this for storing archived storage, and if you want to keep something for a long time, there's different devices to do that. They used to use magnetic tape drives to do this, but again, they have a shelf life. So if you're going to maintain your data for a long time, this is a problem with storage devices, especially when you're archiving information for 40, 50 years. So the semiconductor chips made of silicon, you've heard of Silicon Valley, and what started this whole revolution is the silicon, which allows them to create these chips. They can be either, like I said, volatile or non-volatile. It'd be RAM or like an SSD drive. So the book talks about random access memory, and again, it's volatile. So this is kind of a repeat of what I've just said. It's known as read-write memory, which means I can read the information on it, I can write information to it, but it only works if there's power. It's volatile. Now, cache RAM stores recently accessed memory, and this is a slightly different type of memory, and you'll hear about this cache. It's like having a little store of extra space off to the side for more rapid, quickly accessed information that you need to improve performance of your computer. One thing I always recommend for people who are buying a hardware device is to pay as much money or as much as RAM as they can afford. Sometimes it's not even the processor that's your limitation of how fast things can be processed. It's how much memory that you can store, because what happens over time, we load all our programs, all our data, all our information, and we start running out of memory. And what happens then is the computer then starts swapping that information back and forth from the hard drive or the SSD drive back and forth to the memory, and it slows your computer down. So if you notice your computer slowing down over time, one of the main causes for that is that you have a limited amount of RAM. So one thing you can do to solve that is either one, you can increase your RAM by buying more RAM, maybe go from a 4 gig of RAM to an 8 gig of RAM, which I think is mandatory. I think 8 gig of RAM is pretty much the norm today for most business applications. And if you're a gamer, I'm sure you want to have something like 36 gig of RAM or maybe even more, because games occupy a tremendous amount of volatile memory. So if you can also go in there and start cleaning stuff up. If you clean up your system, it starts taking stuff out of your volatile memory. When you load your computer, that also leads to slowing it down. Now, another type of memory that you should be aware of is called read-only memory. Now, this is memory that has been preloaded with information that your system needs when you turn your computer on. When you turn your computer on, it's like RAM, but it only reads the information. You can't really write to that. So it's non-volatile. You can shut your computer off. It works every time, turn it back on, and that's really one of the key components of starting up your computer. So data cannot be written to it. You can't use it as a working memory. It's used by the basic input-output system or the BIOS system of your computer. Includes the information in the computer system's clock speed, how fast your system is. Other types of ROMs, there's kind of specialty ROMs that you can get, which is called programmable read-only memory. These are called a PROM. So you can program these with special tools, and these are done by developers and programmers. Or erasable programmable read-only memory. That's a mouthful. An EEPROM. And these are allowed you to write to these ROMs and then also erase them and rewrite to them if you need to do an update. Let's say you're updating, like sometimes on your router, you might know that you can get like an update for routers, and your router can go out to the, let's say Cisco, and they can download the updates, and that's basically updating the EEPROM chip in that piece of hardware in your router at home. Now, secondary memory storages, these are kind of some older ones, some magnetic disks. Now, we're still using these. You can still buy these, but they're not as common as they used to be. Magnetic tapes are pretty much disappeared. These are like cassette tapes, almost like VHS tapes. If you can Google that and take a look at those, because these aren't really used. It uses a plastic material coated with an iron oxide on it, and it's used to store information. These do have a limited life, so if you've got these magnetic tapes with data stored on them, they'll only last like 20, 30 years before they start to degrade, and then you lose the data that's on them. And it stores data sequentially because it's on a tape. It's like a rope. You have to go down the rope sequentially. You can't access it randomly, which means that it's slower to read the data because it's got to go through all this tape. Those old movies you see with the tapes going back and forth with those old computers, that's a magnetic tape, and they go back and forth because they're looking for something. They're looking for some data that they're trying to do. Optical discs was a great thing when it came out. Mass storage, it was very quick, but even this technology is pretty much gone. There's not a lot of computers today that are using optical discs, I don't think. I mean, I haven't seen the use of this for quite a while. We used to use optical discs for loading software or playing games, whatnot. But this is also kind of a technology that's fading away. There's other types of storage devices. You probably all have a USB drive because these are very efficient. They're small. They have a large capacity. You get USB drives now with like half a terabyte worth of storage capacity on it, but they are a universal serial bus. So serial meaning it's just singular amount of on-off switches that are going through that cable and a bus. Now, even though they've got 3.0 USB or 3.01 USB, and they're a lot faster now, it's still pretty slow. Like you wouldn't want to, copy a movie onto a USB drive or, and want to have it copied over rapidly. Redundant array of independent disks or RAID systems. This is another one. These are used for servers. And if you're taking a networking class, you'll probably talk about this RAID system for storing and having what they call fault tolerance, so that if there is a catastrophic problem with your data, that you've got a redundancy system in place where they have multiple copies. So basically, you've got multiple storage, and if one system goes down, you've got backups, and then you bring another system online and it copies it over. So you always have two copies, kind of like how cloud storage works. They use a redundancy process in there. So this is found in large networks. It's also found in cloud storage. Now, cloud storage is really where it's going, and that's where I think you guys should all be at. Here at Douglas College, we pay Microsoft a tremendous amount of money to get students cloud storage. You guys, all part of your account, you have a 1 terabyte storage capacity at Douglas College, and it's on a redundant RAID system. So it's also replicated globally. So as you copy it locally here, it's duplicated in multiple servers. Now, because it's an educational institution, we have to be careful with that, because we don't want your data being shared in other geographical locations outside of Canada. So, but as a consumer, if you use something like Gmail or Microsoft's Outlook or Office.com, these are duplicated, and if you travel, though, that data will then be will follow you in a sense at different locations around the world. It's kind of a neat system, and it's free for you guys to use. I would really highly encourage you guys to do that. If you haven't done this already, I would definitely encourage you to go to your office.com and install your OneDrive. So it's the OneDrive that you want. In fact, you can just type in onedrive.com and open up your storage and then install it as part of your Explorer. Let me give you an example of that. All right, so what I've got here on my computer is I've got a cloud drive called Dropbox. Some of you might have one here called Gmail, but I have two other cloud storages for OneDrive. Now, this is one called OneDrive for Douglas College, and all of my Douglas College information gets stored here. And then I have a OneDrive for my personal account, which I think it comes out with 20 gigabytes for free if you guys just sign up with an Outlook.com account. If you have a Microsoft account, you will have access to OneDrive. And what's really nice about this is you guys will have access to a terabyte worth of storage, and all of your information will follow you on whatever device you have. So it's really nice. You just use it. It almost eliminates USB drives. So even USB drives now have been eliminated, which is really a neat thing. So I encourage you guys to get out there and get your cloud storage set up. All right. So I think I've covered most of these. I don't want to cover them anymore in the book here. You know what a TB is a terabyte. You know what a MB is, that's a megabyte, and you have GB, you know what is a gigabyte, and so on. So you can recognize the different types of storage devices, hardware storage, and their capacity. All right, let's carry on and take a look at different classes of computers. I mean, computers have so many different applications that they've come up with specialized areas for each type of computer. So based on how much you want to spend, I guess, and how much memory you need, how fast you need it to go, and how sophisticated you need that computer to be, really determines what class of computer you're going to buy. So computer classifications are broken down into things, you probably have heard of these terms, a sub-notebooks or a notebook. I think Apple uses that term notebook, or a sub-notebook, which is a smaller version of this. It's very thin, lightweight, maybe has a lower amount of memory and speed, but all you need it to use it for is maybe email or some basic office applications. So really you have to look at your capacity. And I find a lot of students, when they're buying computers, they buy computers that are maybe over capacity. Another concern I've seen in classes is a lot of students have Mac computers, and then there's PCs. So which one should you buy? Now, the nice thing with a Mac is that Mac is a great computer. It's great for designing and for art and for a lot of the those types of things like design. The PC is found more in business. So when you're dealing with applications, and and business applications, the PC seems to be a better choice. Also, PCs can be up to half the price for the same capacity as a Mac. So when you buy a Macintosh computer, you're really paying a lot for that ability. So, but the other nice thing about a Mac is that you can get a dual boot and you can put a Windows 10 on your Mac. And I would highly encourage you to do that as well. So you can just Google install Windows on my Mac, and there's some great videos on YouTube to do that. So when it comes down to your personal computer, a Mac is good, and for all my classes, Macs are still good, but there's some programs that show differently. For example, Excel. If you're using Microsoft Excel on a Mac, it's a little bit different than Excel on a PC. And if you're in the CSIS 1190 course, which is just Excel, there's always been a little bit of a problem between the two computer platforms. So anyway, make that little note there. Now, another type of computer that was out maybe years ago, they called it a mainframe. This was sort of the main computer, and then from that computer, it branched off into workstations. You don't see mainframes around much anymore. Supercomputers, again, this is a very specialized type of computer, and this is used for research or medical research, or calculating large problems like weather analysis or a new drug analysis. And supercomputers are, again, have been around for years, and there's some there's current supercomputers that are out there. These are like literally warehouses, rooms filled with computers with multiple processors to do large tasks. Very expensive, very fast, very sophisticated, but these are being replaced or will be replaced by quantum computing. Quantum computers are literally 100 million times faster than supercomputers. And when we ask problems of these supercomputers or these quantum computers, we're going to be able to get answers so rapidly. It's going to change so many things in our lives. For example, if we wanted to find out a vaccine for a particular virus, a supercomputer can find that 100 million times faster than a supercomputer could. So you guys are going to see that probably in the next 5 to 10 years, these supercomputers coming out. Now, you'll hear the term server a lot. And a server is basically a large computer that has a fairly specific task and a specific software to perform. So you'll have something like a file server that stores all the files, or you'll have a print server that's dedicated for just sending print jobs, or you'll have an internet server that helps direct traffic, and so forth. So servers are central computers with very specific tasks that multiple people tend to access. All right, so here's a couple other ones. Servers. You have a database server, so servers that are just dedicated to storing all the data, or even a fax server. Like this is a very old type of server. We don't really use fax servers anymore. We attach files in emails and send it. File server, like I said. Email servers are still around because everyone still does email, and you'll hear this thing like POP3, which is Post Office 3 protocol servers, or SMTP servers, or IMAP servers. These are all email type servers, remote access servers, and web servers to keep track of the internet. So usually a server has a dedicated type of task that it performs, and multiple people connect to it. And the people connecting to a server is referred to as a client. So the client is who accesses the server. All right. We've talked a bit about programming. Programs are synonymous with software. This is what it gives the computer hardware its intelligence to perform a very specific task. These software programs kind of work in the background that provide a GUI, tend to be a GUI for the user to allow them to be able to input data and create files. Application software, and when we're talking about managing information systems, we're talking about primarily software. So MIS is the software, although people might argue that managing information systems also has a hardware component, which it definitely does, but the systems themselves are software that were developed by programmers, and essentially they're a program. Operating systems. Now, with operating systems, the operating system helps control the hardware and the software. So the operating system kind of sits between the hardware and the software. without the operating system, you wouldn't be able to communicate between the two. And there's kind of different operating systems that are out there. You know, there's the Windows operating system, which is probably the largest out there. And then there's Mac iOS, and there's other ones like Android. And in your cell phone, every type of computer has to have some kind of operating system to communicate between the software and the hardware. So your phone will have either an iOS for an Apple, or it'll have like an Android operating system. And there's other ones out there. And Android is an iteration of a Linux operating system. You'll hear Linux or Unix operating systems, or other types of operating systems that are out there. And again, it helps to make the computer more efficient. It helps them control their files, helps to control the peripherals, helps to talk to those different devices. So again, the operating system, it helps control these programs and manage the hardware resources by performing job management. So when you ask the computer to do a task, yes, the software to do a task, and it has to coordinate with the hardware, they refer to this as job management. And you get job management, you can sort of see job management when you go into the background of the operating system. So let me demonstrate that. If you go Control-Alt-Delete and go into Task Manager, you're looking at kind of the jobs in your computer. Now, these are software programs that are being managed by the operating system. So I've got Google in here, I've got Excel open, I've got Outlook, and so on. These are all the different programs that are running. Plus, there's software programs in the background that help manage my computer. So things like if I'm running Adobe products, or if I'm using a particular computer to talk to my storage systems. So this kind of shows you very specifically that the operating system helps control all the background software programs and the application software as well. So it's called the Task Manager. You get access to it by Control-Alt-Delete. And this is a great tool to know about in case you've got a program that's going a little bit rogue. So if you've got a program that you're trying to execute or get rid of, let's say the Snap tool right here, I've got it running here, but I don't want it. I can take it out by just selecting and say end the task. And there I go, I've ended that particular one. Now, this is my Smith Tech. This is what I'm using to record this video at the moment. So if I clicked on that, it would kill my video and I wouldn't be able to do anything right now. All right, so that's a little bit about how the job management goes in your operating system. It helps, the operating system also helps to allocate the resources. So it also, if you saw in that previous example, it shows how much of my processor is being used, how much my memory is being used. So again, I'll just go Control-Alt-Delete. I'll open up that Task Manager one more time. And it says here, there's my CPU. That's the central processing unit. How much am I using at the moment? This is my RAM memory at the moment. So I'm using 82% of my RAM memory. So it's kind of getting high. It's because I've got a lot of memory being used up by my Chrome. I've got a lot of tabs open. So if your computer starts running slow, recommend going through and cleaning up and getting this memory down. To run your computer efficiently, it's around 66% to get sort of an optimal memory management. And then this is my storage disk and my network capacity as well. And you can see here, this is my graphical processor unit. This is what helps my graphics card and my graphics engine. So it gets into a little more detail. So the key stuff right here is probably these three right there. So the data management, it helps organize your data. It helps to set up your communications. So without the operating system, your computer is just not going to work. And hence what Microsoft's first major software program or system was the disk operating system. They called it DOS, and that's what launched Microsoft. And why Microsoft's so big, because without an operating system, your computer just won't work. It won't talk to the software. There's supervisor programs out there called the kernel. Now, these are more deep-rooted, and these are systems that are more embedded into the system. And from a user point, we really don't use this very often. This is used by more advanced people that are building software to communicate to specialized hardware devices. So responsibility for controlling all other programs in the operating system. So like I showed you earlier there, these are the background programs. The kernel helps organize that, but so does the operating system helps with that as well. Application software. This is really where you guys are going to be shining here. So I think what I'll do is, before I get into application software, because this is a talk on its own, I'll cut this video short or not short, it's already 30 minutes. And I'll let you guys watch that in the next video.